Hello, today we are going to discuss about subnetting of class A and class B. As previously we have done the subnetting of class C, same way we are now doing the subnetting of class A and B. So in this we will first done the subnetting of class B. Why we require the subnetting of class B, as we have done the class C subnetting. So as we know that in class C contain only 254 IP address in total. But as we require more IP address in the network, so we will go with the subnetting of class B. As class B contains 65,536 IP address in total. So as class B contain large number of IP addresses, so we will count from the least significant bit to the make the calculation easy, or we will start the counting from the last bits that we borrow from the host bit to the network bit. That in this we have taken the example that 172.16.250.12/16 is the IP address that belongs to the class B. Here 172 in the first octet indicate that is the class B IP address, and /16 indicate the subnet mask, that is 255.255.0.0. So here this subnet mask indicates the network bits and the host bits. So first two octets represents here network bits, and the last two octets represents the host bit. So here the total number of host bits are equal to 16, as it covers 2 octets. So here to calculate the total number of IP, we use the formula 2 raised to power n, where n is the total number of host bit. So 2 raised to power 16 gives 65,536 total IP addresses, from which the 2 IP addresses are invalid, that we don't use in the network, as these IP addresses are network IP and broadcast IP. So we subtract the 2 from the total IP addresses, then we will get the total valid IP addresses which can be assigned in the network, that is 65,534 IP addresses. So now we will start with the subnetting of this IP address. So to do the subnetting, we here borrowing the 5 bits from the host to the network bit. So here we are borrowing 5 bits from the host to the network. So we will remain with 21 network bits and left over with 11 host bits. So here there are 21 network bits and the 11 host bits. So now we have to calculate how many subnets are created by doing the subnetting. So here we use formula 2 raised to power n, and is the number of borrow bits. So here we are borrowing 5 bits, so 2 raised to power 5 gives 32 subnetworks, and the valid IP address in each subnetwork is 2046, which is get by calculating 2 raised to power n minus 2, where n indicates the number of the left bits. So each subnet will have 2046 IP address in total. So these now the 32 subnetwork created are shown as here 172.16.0.0/21, where 21 is the number of network bits after borrowing a bit. So here this is the first subnet, and the next subnet is 172.16.8.0/21. So here 8 in the IP address comes from by counting the bits from the last significant bits, that is the last bit of the IP address which we will borrow from the host address. The value of the last binary bit is 8. So here the subnet is 2, or by adding the 8 to the other IP addresses, we get the subnetwork IP addresses as 172.16.0/21, that is subnet 3, and same way 172.16.248.0/21 is the subnet of subnet 32. Next is subnet mask. As earlier defined that /21 is the subnet mask of this subnetworks, and the decimal notation is 255.255.248.0. So here 248 is the last address of subnetwork, is subnet mask of all other network. So here in the last subnetwork is subnet 32, and the IP address of subnet 32 is 172.168.248.0. So here 248 is the subnet mask of the these IP addresses. So now we have to calculate the host range or the other IP, valid IP range. So here we have shown the each subnet, their network IPs, their broadcast IP, and the valid IP addresses or the host range. So each subnet have their own network IPs and broadcast IPs and the valid IP range. So here the first subnet has 172.16.0.0 and its valid range starts from 1 to 6 and end up with broadcast IP address that is 172.16.7.255. So same way the next subnet starts from the 8 and its valid IP address range from 9 to 14 and the broadcast IP address ranges end up with 15.255. So same way the other subnet has the same IP address, valid IPs and the broadcast IP. The next is subnetting of class A. So how to do the subnetting of class A? So here the given IP address is 10.0.0/8. So here 10 in the first octet indicate that this is the class A IP address and /A represents the subnet mask, that is 255.0.0.0. So here it indicates the network bits and the host bits. So first octet represents the network bits and the last 3 octet represents the host bit. So here the total number of host bits are 24 as it represents by 3 octet. So 2 raised to power 24 gives 16 million total IP addresses. So here we get, if we want 16 million IP addresses, we want to design a network. Here we require 16 million IP addresses. We will go with the subnetting of class A. So now how to do the subnetting of class A? Here we will borrow 11 bits from the host to the network. So here we are borrowing the 11 host bits. So we will get left with 19 network bits and the left over 13 host bits. So the how many subnets are created here? 2 raised to power n, where n is the number of borrow bit. So we have 2048 subnetwork here. So we are creating 2048 subnetwork and each subnetwork will contain 4190 valid IP addresses. So these are the range of the valid IP addresses in each subnetwork. So these here we are showing the 2048 subnetworks which are created by doing the subnetting of a IP address. So it have the subnet mask of /19 and each subnet ends with like 10.0.0 and then next IP address is 10.0.32.0, then 10.0.0.64.0. By adding the 32 in each IP address, we will get the subnet mask of the subnet IP address of the next subnetwork. So the subnet mask, how to calculate the subnet mask? So 255.0.224.0 is the subnet mask of this IP address. So last address of subnetwork is 244, end up with 224. So here 224 is the subnet mask of the IP address. Similarly, we can find the host range as we find in the class B and class C. So this is all about the subnetting of class A and B. So thank you.